This is the 2024 Deferred Paper 1. It's a calculus question from section B, and it's question 8. So just to read what's going on first, a company produces firewood, and to make the firewood they cut the wood and leave it in the warehouse to dry out. So this is about the water content in the wood, the water content which is called WT. It's a function of time. And so what WT stands for in this equation here is the percentage of water in the firewood, WT, and T is given in weeks. So basically it says down here T is time in weeks, so all these things are in bold for a reason. The percentage of water is W, and in capitals again, or in bold, weeks, is the time T. Okay, so the first part of the question is to work out the water content at the start of the drying process. So the basic idea is you got this wood, it's drying out, there's a percentage of water in it at all stages, and common sense tells us the water will go down to zero eventually, it'll totally dry out. It's only a matter of what is the time it takes to do that. And that's what the equation is working out for us. And at the start of the drying process, so you've got to realise in the exam, it's like converting English to maths language. English is at the start of the drying process. In maths language, that means T equals 0. You know, the time in weeks is 0 at the very start. So you put in 0 for T, and you get e to the power of 0, which is 1, and you get 5 plus 20, which is 25. So WT is 25, and we're told again that this is the percentage of water in the wood at the very start. So the wood starts off with 25% water. After 8 weeks here, again convert English to maths, that's a good exam technique, and 8 weeks means T equals 8 in maths language. So put in 8 for T, work it out in your calculator, you'll find it's 15.6, and he wants it rounded off to the nearest percentage, so that's 16% water after 8 weeks. So it has dried from 25% water down to 16% water in 8 weeks. The company will sell the wood once the water is 10% or less. In other words, W is 10. So that's, convert that to maths language again, W is 10. So fill in 10 for W. And okay, here's the rest of the equation. We're looking for T this time, so we must get T on its own somehow. So that means get rid of everything else that's in the way here. First of all, 10 minus 5 is 5. And that just leaves the 20 times E. So, and now divide both sides by 20 because we want to get at the T here. So that gets that 20 out of there. Divide both sides by 20 and that's now gone. And you have a quarter on this side equals e to the power of that. Now at this stage the tables helps us. We need to be able to go from powers to logs fairly fluently. So if you apply this formula here from your tables, in the log section of your tables, you'll see that you can rewrite this as the log to the base e of a quarter. So basically logs are powers backwards. So when you go backwards, the log of a quarter is that number up there, minus 0.079 to the power of t. Log to the base e has a shortcut name. It's called natural log ln. So we can replace that with that. So the ln of a quarter is now equal to that. This can be worked out on the calculator. And we've got this over here. So t is now that over that, which is 17.5 weeks. Now the examiner has given you a hint here. Be careful again. The word, watch out for all these words in bold. They're very important in an exam. The examiner does that to help you. So we're talking about days here. The trouble is T was in weeks. If you go back to the start of the question, T was in weeks, but he now wants the answer in days. So you must multiply by 7 to get the answer in days. 122.5 days. Now the way the question is phrased, he wants it to be, so the amount of water is going down the whole time. So what I did was I made it equal to 10. Now it's going to be less after that. So whatever time we got after that, it'll be going down less than 10. So that's what the question asks. When will it be below 10? So in terms of full days, I mean basically after 1, 2, 3 days, if you round it off, you'll be definitely less than 10 from then on. Okay, so that's the 1, 2, 3 days. Now, section C. Work out W-5, where W dash is the derivative. Okay, so he's asking us directly here to get the dy dx. or the derivative. So you write down your function and you go along in a line here, and you get, okay, if you differentiate 5, you get 0 because that's just a constant. Now, how about the 20 times this? Well, a number in front, the technique is it just stays as it is, so that 20 is just 20. Take e to the power of over here. E is the only function that stays itself. So if you take that e to the power of up here, it stays itself there. That hasn't changed either. Now there is one thing. I think of this as like a plot and a subplot. The main plot is that there's e to the power of something. So e to the power of something stays as itself. But there's a subplot, which is the minus part here. And you must differentiate that separately. So something times t is just the number in front is the answer when you differentiate. It's like 3x becomes 3 when you differentiate. So when you differentiate this, the t drops. And the main plot, which is the e to the power of, and this part here, you multiply them together because of the chain rule. So this is the bit that people leave out, so watch out for this little bit over here. Okay. Now tidy up with the calculator, you get minus 1.58 times that. Okay, so that's w dash t for any value of t, but he wants w dash 5. So now it's just a matter of subbing in 5 for t into the equation. And you get an answer rounded off to 2 decimal places. So watch this bit as well. Always these little bits are worth the mark. So watch out for that. 2 decimal places, 1.06. So it's minus 1.06% per week. So what are we actually saying here? When you differentiate, it's a rate of change. So we're talking about how much the water content is changing in the wood per week. So it's losing. What this tells us is basically we're losing 1.06% of the water content per week. That's how much it's drying by. Now, part D is more abstract. It's trying to get us to understand what's really going on here. And what it's getting at is this: w dash t is always negative, always less than 0. That means what we call a decreasing function. You know, whenever you differentiate a function and it's less than 0, that's a decreasing function. So that's something we should know. Decreasing functions, the derivative is less than 0, increasing is greater than 0, etc. So what we're trying to say here basically is simply the percentage of water in the wood is always decreasing. So what's happening here basically is as time goes on, it's common sense anyway, but the maths confirms it. As time goes on, the amount of water is decreasing. So that's what w dash t is telling us. Okay. When I say the amount, I mean specifically percentage, because that's what W stands for. WT is the percentage. So the percentage of water in wood is always decreasing if it's always negative. Now the next thing is basically this modulus idea. That's just the size of it. In other words, we ignore the minus. So the number itself is what we're interested in, which is the 1.06. So we're ignoring the minus. If that's getting smaller, what does that mean? So basically, if that number is getting smaller, that means that the percentage of water per week is getting smaller every week. So the amount of water, we're losing water every week, but the amount we're losing every week is getting less. So that's worth repeating. We're still losing water every week. The percentage of water is always decreasing, but the percentage of water lost per week is getting smaller every week. You know, we're not losing as much water because it's drying out now, you know, as we go along. Or another way to say it is the d2y dx squared, I suppose, is getting smaller. Okay, so eventually there will be no water left. If you think about it logically, then if we keep going on and fast forward time, eventually obviously it will all be dried out. Okay. Now, the next part, so the company that's drying out this wood, they're building a new warehouse, and it turns out in this new warehouse the wood dries faster. Now again, there's that bold. Watch out for that in the exam always. We're trying to help you here, the examiner, trying to tell you something that's important. So it dries out faster. So it's basically losing water more quickly. And this is the new function that describes the percentage of water left in the wood. So it's different to the W function. Okay, and the thing is, we don't know what K is. K is some number, we just don't know what it is at the moment. Now, on the graph below, we're actually, what's drawn for us, this one here is what's given to us. We're given WT as a graph. So you can see here that the water is, the percentage of water is reducing all the time until it gets to the 10% eventually, or lower. So the percentage of water, it starts at 25. We know this because if you look at the original equation for WT, it was 25 at 0 in part A. So we know it starts at 25 and it's 25% water, and it's losing its water content all the time. It's going down, down, down until the end. What we're asked is to draw a new graph. If you're losing water faster in the new warehouse, what would that graph look like? Well, if you're losing water faster, it still starts at 25% water at the start, because we can see here 5 plus 20. If t is 0, it's going to be 20 plus 5. We weren't even asked for this part up here anyway, but just to show it. So it starts at 25, and you're losing water, but at a faster rate. So as time goes on, there's less water content, as you can see. So for example, if this was 1 second, after 1 second or 1 week, there's less water than there was in the previous warehouse up here. So we've less. It's always a less, basically. And that's all we can do. It just says sketch, so we don't know anything else about the graphic part, but it's less than the first graph. It's below the first graph because we're losing water quicker. It's drying quicker. Now the next part, write down one possible value of K. So we want to get more specific now. If this graph is definitely less than the other graph, we're going to recall for a second that the first graph was 5 plus 20 times e to the power of minus 0.079 t. So we want to replace that with K in the second graph. That's where K is in the second graph. So the number is not known this time. If we can replace that with some number K, that blue from the previous one, from WT, with something called K, which is definitely going to show that it's losing water at a faster rate. So what can we make K? Have a closer look. Using your rules of powers, e to the power of minus becomes 1 over e to the power of plus. That's in your log tables under indices. Now, have a look at this again. That number there, the bigger it is, in other words, the bigger under the line is. In any fraction, make under the line bigger, the fraction is smaller. The overall fraction is smaller. So the bigger that number is, the smaller the overall fraction is. And that means we know now a way to make this smaller, quicker in other words, because again, that's WT. So if this part is getting smaller, well, WT itself is getting smaller. So the percentage of water is getting smaller in the same time. So basically, as long as we pick any number there that's bigger than the existing number, we're sorted. Any number you can pick that's bigger than that will do it for us. For example, 0.1 is bigger than 0.079. And lastly, not forgetting our minus when it goes above the line again. So the minus number there. So basically any number like 0.1, 0.2, whatever, would be a good enough answer here. We just want one value that describes this. And that's it. Now on to the last part, which isn't calculus at all really. It's more based on financial maths, but we'll have a go anyway. So go back to financial maths for a sec. Basically, the firewood company, the wood they produce increases by 6%, 8% and 17% each year. So it's 6% on the first year, it's 8% of that amount the next year, and 17% of the final amount there again. So after 1 year, your money's worth 1.06 times your... Okay, we'll put in this money in financial maths for the moment, even though it's firewood. So P is your firewood, I suppose, at the start. So after 1 year, you've 1.06 times your firewood. After 2 years, you've 1.08 times that again. After 2 years, 3 years, you have 1.17 times all of that. So your final amount is P times all of that. Now, so basically what we're saying is your firewood, your amount of firewood at the end is 1.33 times roughly what you had at the start. Now in terms of interest or increase every year, what's that equal to? So there's a formula in the tables which we can use, or basically you can just take your interest, your final amount to the power of a third minus 1, and that's your rate over 100 basically. So what we're doing here is it's kind of like, if you think about a monthly interest rate is always 1 plus your yearly interest rate to the power, in a bracket, to the power of 1/12 minus 1. So it's the same idea. So okay, so and that'll give you your interest rate, or in this case your rate for the firewood. So basically that works out to be 0.1023, and as a percentage that's 10.2%. So what we're saying is that these three separate interest rates are the equivalent of losing 10.2% per year. Or sorry, increasing, is it? In this case, yeah, the increase is 10.2% produced per year. And that's the end of the question. So in the next video, we'll go on to question 9.